Hello, this is Mr. Best. Welcome to Chapter 9, Homework Questions 45 through 52. Question 45. Koi is inflating a spherical balloon for her brother's birthday party. She has used 3 full breaths so far, and her balloon is only half the width she needs. Assuming that she puts the same amount of air into the balloon with each breath, how many more breaths does she need to finish the task? Explain how you know. Alright, so where is some important information that we need to pull from? She has used 3 full breaths. Let's change the color there. 3 full breaths so far, and her balloon is only half the width she needs it to be. So she needs her width to double to make it what she wants. So therefore, our linear scale factor is going to be 2, because she wants it twice what it is right now in terms of the width, which means since we're doing volume, r cubed is equal to 2 cubed, which is 8. So it needs to increase by 8 in terms of the volume. So what do we have? Well, if she has 3 full breaths so far, she's going to need 8 times that, which is 24 full breaths total. It does say how many more will she need. Well, she needs 24 total, so she already did 3. So we'll subtract that 3 off, and she's going to need 21 more times to blow into the balloon the same amount to make sure it gets to the size that she wants. Question 46. Draw a cylinder on your paper. Assume the radius of the cylinder is 6 inches and the height is 9 inches. So let's see what we can do here. Alright, there we go. We have the height as 9 inches, and then the radius will be 6 inches. What is the surface area of the cylinder and what is the volume? So surface area, remember when you take a cylinder and you kind of cut it along that line and open it up, it will form a rectangle. And then you'll have a circle, and then you'll have another circle down here. So the surface area, you have this is your 9. This length right here, if you wrap it back up, would be the circumference. So the circumference is 2 pi r, and so that is 2 pi times the radius is 6. So we know this dimension is 12 pi. So 9 times 12 will be 108. So the area is 108 pi. I'm just going to leave it like that until I calculate everything. And then the circles, we have radius of 6, and the area there is pi r squared. So the area is pi times the radius squared, 6 squared, is 36 pi. And since there's another one over here, that's times 2. So therefore, the surface area is equal to 108 pi plus 36 pi plus 36 pi, or 2 times 36 pi. So the surface area is equal to 180 pi, and this is in inches squared. So that's the exact answer, but let's also get the approximate for the surface area. And that'll be approximately 565.5 inches squared. All right, next part is the volume. So let me move this up a little bit here. So for the volume, this is still part A. For the volume, we need to figure out what the area of this bottom piece is, which we already did, and that's 36 pi. So we need the 36 pi, and then how many levels it has, which is 9. It's the height of 9. So volume will equal 324 pi, and then once again we'll approximate that, and if you plug that in you should get 1017.9. Volume is measured in cubic inches, so there's the volume. Part B, that was just part A, so then part B, if the cylinder is enlarged with a scale factor of 3, what is the volume of the enlarged cylinder and how do you know? So if the scale factor is 3, since we're doing volume, we're looking at r cubed, which would be 27. We should be able to take 27 times our original volume of 1,017, or 324. If we write it as 324 pi, this will give us our new volume So that will be approximately 27,482.65. And once again measured in inches cubed. And so that's the enlargement when you have a scale factor of 3, and it is volume once again, so r cubed, so it grows 27 times what the original figure is. Question 47. While Katerina was practicing her figure skating, she wondered how far she had traveled. She was skating a figure 8, which means she starts between two circles and then travels on the boundary of each circle, completing the shape of a sideways 8. If both circles have a radius of 5 feet, how far does she travel when skating one figure 8? So the radius, it says, was right here, 5 feet. Same thing over here. And so we're trying to basically figure out the circumference. So the circumference is 2 pi r. 2 pi times the radius is 5. So let me fix that. It looks weird. 2 pi times 5. That would be 10 pi. And there are two circles, so you're going to take your 10 pi times 2. So that gives us 20 pi for the total distance. And so then we can calculate that approximately. So the total distance will be equal to 20 pi, or approximately 62.8 feet. Question 48, for each triangle below, solve for x. If possible, if no solution is possible, explain why. So we're looking for the value of x. This is not a right triangle, so we're going to have to use our law of sines and cosines. On this one, we can use our law of sines. We can say sine of 80 degrees, since that's the length we're looking for, is across from x. And we can use the length of 10, but we need this angle right here. So if we take 180 minus 80 minus 27, that'll give us 73 degrees. So we can do sine of 73 degrees over 10. And then now we can multiply. We can either cross multiply if that's how you were taught, or you can multiply by 10 and x. What you'd end up getting would be 10 times sine of 80 degrees is equal to x times sine of 73. We're trying to solve for x, so we'll divide by sine of 73 degrees. And then x will be approximately 10.3 units. For part B, we have this leg is 8, the hypotenuse is 6, and it is a right triangle. So you might recognize that the hypotenuse is actually smaller than the leg, which is a problem. The hypotenuse is always the longest side of a right triangle. So on this one, there is no value for x that makes sense. So there is no solution for this because the hypotenuse is smaller than the leg. Part C, we have a 30-degree angle here. 5 represents this side length, and we're looking for x. We also have the height of the triangle, which is 6. So if we look at the bigger right triangle instead of the smaller one, if we look at this bigger one, this is 30 degrees, which makes this angle, the whole thing, 60 degrees. So if you know your special right triangles, we know that this leg over here, which is the 6, and the long leg over here has to be the square root of 3 times your short leg, so that's 6 square roots of 3, which means then we can piece off and figure out what this length is right here, because if this whole thing from here to here is 6 square roots of 3, then I can subtract 5 to figure this one out. So 6 square roots of 3 minus 5 would be that length. And we can plug that into our calculator, and then because it's a right triangle, we can find x by doing Pythagorean theorem. So this length right here is approximately 5.39, so we can do Pythagorean theorem. 5.39 squared plus 6 squared is equal to x squared. And then we can take the square root of both sides, so x would be approximately equal to 8.07, and that would be in units. Question 49. The map plan for a three-dimensional solid is shown at the right. On graph paper, or on paper, draw the front, right, and top views of this solid. So as we draw the front view, we're going to look at this first column here, and the depth in terms of how high it is 3, so I'm going to go all the way up to 3. The next column, the highest is 4, so I actually got to create another square there. And then on the next column, the highest is 2, so I'm going to go all the way down to 2. And so all of this will be shaded in, so that's what we see. On the next one, we're going to look from the right, and we'll look at this bottom row here. The highest is 3, so we'll go up to 3. On the next one, the highest is 4, so we're going to go up 4. And then on the top one, the highest is 3. So we'll have all of that filled in, including that extra spot on top right there. So that's what you see. And then from the top view, we're just looking straight down. So any of the missing ones here and here, we're not going to see. Everything else we'll see. So we'll just take those two pieces out. And that was what you will see on the top view. Alright, so that's part A. Part B, find the volume and the surface area. Well, the volume is just going to be all the blocks added together. So we just look at the map plan. We have 5 here, 5 here, and 5 here. So that's 15 with an extra 1. That's going to make 16. So that's 16 cubic units. And that is for volume. Surface area. We'll look at the front, right, and the top, and we'll just double them. So the front, you have 3, 3, 6, 9 times 2, because you're going to get the back as well, that's 18. 3, 6, 9, 10 times 2 is 20. That'll be the right and the left. And then the top, you have 3 plus 4 is 7, which would be 14 from the top and the bottom. So if we add all those numbers up, we will get 52, and this is surface area, so units squared. Question 50. The graph of the inequality y is greater than 2x minus 3 is shown below, or in this case to the right. On the graph paper, graph the inequality y is less than or equal to 2x minus 3. Explain what you changed about your graph. So it's still the same boundary. 2x minus 3, we have a slope of 2 with a y-intercept of negative 3. So we'll go up 2 over 1. And that's the same thing that's happening here. Realize that their line right here is dashed or dotted, where this one, because it is equal to, it is going to be a solid line as we draw it. So that's one difference. And then the other thing is that when we test this point 0, 0 into the inequality y is greater than 2x minus 3, 0 is greater than 2 times 0 minus 3, 0 is greater than negative 3. That is true. Where when we test the point 0, 0 on ours, it'll be 0 is less than or equal to 2 times 0 minus 3. Is 0 less than or equal to negative 3? That is not true, so we don't want to shade in that direction. We want to shade in the other direction. So we'd be shading down here on our line in our linear inequality. So the difference is where you're shading, and then also your boundary line is now solid. So boundary line is solid and shading is below the line. That's what changed. Question 51. An international charity builds homes for disaster victims. Often the materials are donated. The charity recently built 45 homes. 20% used granite for the kitchen countertops, while the rest used porcelain tile. 15 of the homes used red oak for the wooden kitchen floor, 20 used white oak, and 10 used maple. If a disaster victim is randomly assigned to a home, what is the probability in a percent of getting an oak floor with granite countertops? So since we're looking at two different things, we're looking at countertops and the wooden kitchen floor, I'm going to set up an area model for the three different types of wood floors and the two different types of countertops for the kitchen. So I went ahead and set up the area model. I got red oak, white oak, and maple on top, and granite and tile on the left side. I also put the 20% with granite and 80% with tile because the rest used the porcelain tile. We have 15 out of 45 homes on the red oak, so that's 15 out of 45, which can be reduced to, reduce that a little bit more by 1/3. The white oak, we have 20 out of 45 homes. So divide that by 5, and you get 4/9. And then the maple, we have 10 that use the maple, so that's 10 out of 45, or 2/9. So now to figure out which ones, we need to multiply those two together. Since the percents, we have fractions and percents, let's go ahead and change 20% to 20 out of 100, which reduces to 1/5, and 80 out of 100, which will reduce to 4/5. And then let's just multiply. So we're looking for randomly selected of an oak floor with a granite countertop. So oak floor, so it could be red or white oak, and the granite countertop. So we're looking really at those two squares only. Rectangle. So 1/3 times 1/5, that's 1/15. And then 4/9 times 1/5 is 4/45. And so then we can add those two up. 1/15 plus 4 out of 45. We can find a common denominator. That would be 3 out of 45 plus 4 out of 45, which would equal 7 out of 45 of the homes would be oak floors with granite countertop. And if you divide 7 by 45, because it wants it as a percent, we'll get approximately 15.6% of the homes will have oak floor with granite countertops. Question 52 is multiple choice. The point A, which is at -2,5, is rotated 90 degrees counterclockwise about the origin. What are the new coordinates of point A? So remember, if you have tracing paper, you can plot that point and then create that little crosshair in the middle and then rotate it counterclockwise 90 degrees. And if you do that, your new point will be located at -5, -2, which would then, we'll call it A prime, and that would be part D, -5, -2.